Hi everyone, this is your last video for Unit 2, talking about applications of absolute value inequalities. So we've been spending time talking about how to solve them. Now we're going to tackle some word problems with them. Now first I want to go back to the definition from absolute value that you remember when you first learned about the notation. And it measures a distance from zero. And so if we talk about a graph and we look at something with 0 and we talk about, say, the 2 points -4 and 4, their distance from 0 is 4. So we can say the absolute value of whatever number it is going to be 4. Now, absolute value can also measure distance from some other numbers. So if I want to talk about the distance from, say, 3 instead of measuring from 0, and again, if I'm on the number line, I'm using 3 now as the center point. And if I go 4 in either direction, if I go 4 in either direction and I want to represent that, I can say that the absolute value of x minus 3 is going to equal to 4. And so this number that I put in here is where I'm measuring my distance from. And we can use that idea to write some inequalities. So if we translate some basic expressions, we say n is no less than 5 units from 8. And this from 8 tells me where I'm going to center my absolute value from. So I want to pick a number that from 8 I am no less than 5 units in either direction. Now, since I want to be no less than 8, I want to be no less than 5. I want to be more than 5 units from either side. And so I'm going to do the absolute value of some number minus 8. That's my center. And I want this distance to be greater than or equal to 5. So there's the translating expression for no less than. Means I want it to be that number or bigger. Second one says x is no more than 18 units from 2. So again, the from 2 is where I'm measuring my center from, or -2, and I want to be no more than 18 in either direction. Well, no more than 18 means I want to stop and be inside this boundary of going from 18 in either direction. So here I'm going to have my value of x from my center, so minus -2, and I want it to be on the inside of the interval, so no more than 18. Okay, that could also be written as x plus 2 is less than or equal to 18. Okay, a couple more examples. We're just practicing the translating. Tolerance, another word instead of no more than or no less than, you'll say is within units of 6. And again, here's my center for the 6. And so I want the absolute value of n minus 6 to be within. That means less than 0.001. And then finally, I can start throwing in other functions here. So we have a value for y, and we want y to be within 0.01 units of 4. And there's my center for the 4. So it's the absolute value of y minus 4 within is less than 0.01. But up at the top, they give me some information about what y is supposed to be, and so I can replace this y with 2x plus 1, keeping the rest of it as is, simplify what's inside, and now I have 2x minus 3 in the absolute value is less than 0.01. And so for right now, you're just working on, can you translate these things? I think probably the hardest thing is going to be keeping track of the no less than. It's actually the opposite. No less than means you want it to be more than that amount. No more than means you want it to be less than that amount. We'll do some more of these in class, but for now your assignment is just to take page 166 and take a look at 77 through 82. Why don't you go ahead and try 83 while you're at it and see how that goes. And if this is just practice writing the inequalities. Thanks, and we'll see you later.